Okay, so this is the last chapter from your syllabus in the order wise, that is particle physics. And particle physics is more likely to be the same concept in the nuclear physics that you already studied in your IGCSE. The very first topic is related to the Rutherford model, right? Do you know about that Rutherford model?
Yeah, I think
That was related to that gold foil experiment.
the one where they like shoot the beam of electrons
Yes,
and then they, yeah.
yes. And they some of them just pass through without any deflection, and from the center they will deflect back, and some will deflect with greater angle, right?
Yeah, because like it's like showing that there's alpha, beta, and gamma like different types of rays.
Yes, and we can say that the central part of the atom consists of nucleus, so that's why from the center it will deflect back. So 90% or 99% of the mass is concentrated in the center, right?
Yep.
So if you have because this concept is very much simple and most of the students already know about this concept, so if you also have this concept, so we just skip this uh, concept right now. I'm just writing the name, so that will remember you that you need to study this concept is the same, that central part contains the nucleus, electrons are revolving around the nucleus, and protons and neutrons are in the center of the nucleus. So that is the
That's
all
like
theory.
it.
Yes.
That's it in the Rutherford's model. Like that's the only thing in it.
Yes, because that is the same repeated topic from your IGCSE, right?
Nothing's added, right?
No, the new thing that will include it. So I will also explain you that what is going to be included in that. Otherwise, it means that you need to revise the same concept from the previous one, right?
Okay.
And second thing is related to the atomic structure. And strong atomic structure means the same. You know that the central part consists of proton and neutron, right?
Yeah, and then there's like the nucleus, and then there's the electrons orbiting it.
Yes. Protons plus neutron, and the outer side means electrons are revolving. So in atomic structure you need to know about this concept, and then you need to know about the charges. You know that proton is positively charged, neutron is the neutral one, and electron is negatively charged, right?
Yeah.
And neutron is the neutral, no charge on it. So this is the same concept that we already know about this. And further, if we talk about the new concept that is included in your particle physics, that is related to antimatter, right? Because we talk about matter, we talk about particles, but there is a new concept of antimatter. So this is the new topic in your particle physics, that is antimatter.
So is it like the opposite of like matter?
Yes, but you need to know about some sequence, you need to know about some names and the charges and the values. So that will be the new concept, and the
Oh.
sense make the same, that it is anti to the matter, right? Just like if
Yeah,
we
but
Mhm.
wait, if so when like matter is created, antimatter is also created.
Yes, if we take the example of electron, so electron has negative charge, so it means in antimatter there will be some particle like electron but having positive charge. So that is
So
actually
it'll
the
have like a
particle
negative
physics.
charge.
Yes.
Also, do like when antimatter and matter like do they react or like
Yes, there is a combination. that we will also discuss that how the nucleus is going to be formed, or what particles are going to be included, or what antimatters are going to be included to make different formations and different structures. So we also discuss that. Okay.
Okay.
And you already mentioned that each matter has antimatter, so all matter particles have antimatter, right? So basically, if we want to write for the antimatter, so we can just simply write it as antimatter are the particles. These particles are identical to their matter counterpart, but the only change is of the charge, right?
All right.
So that is the only difference that we have, that there will be a different charge. So in this concept, we need to talk about different charges plus their names. So we are having now different particles with different names. So let's suppose the same concept, if we are having a positive charge particle, so it antimatter will be like same identical but with different charge, that is negative, right? So that is the
Okay, so
concept.
they cancel each other out, like how there's electrons and protons, so there's also matter and antimatter.
Yes. So all exist in the antimatter state also. If we are having any matter, so there will also be an antimatter, right? So let's suppose if we consider the electron, for example, and the charge on electron is -1. So the opposite particle, that is the antimatter of electron, is known as positron, right? So this is the antimatter of electron, and the charge of this positron is +1, right? So positron is the antimatter of electron, just like if we take the example of proton and
So
neutron.
the opposite of electron, like in
Yes,
antimatter. So in matter, it's called electron, but in
yes.
um, it's
Antimatter
called positron
in
in
antimatter.
antimatter.
Yes, so that is the concept. So same goes for proton, but the name of the particle will be different, and we also going to discuss for neutron.
What's it gonna be called in antimatter for proton?
Yes, because these are the fundamentals. So first of all, we need to know about these. Then we will discuss about some other. So for proton, we are having antiproton. It will be not like the same just positron. So this will be -1. And same goes for antineutron.
So basically, they're like repelling each other. So like that, like they're like opposite of each other. So if
Yes,
electron is -1, so in the other one, the positron will be
positive one.
+1.
Yes.
And if proton is having +1 charge, that means in the antimatter, it's gonna be called antiproton because it's -1 of proton charge.
So that is the
But
simple concept.
isn't antiproton and electron kind of like same, and proton and positron?
Actually, electron and anti proton are like the same, just like positron and proton, but antiproton only exists with proton, right? Because in definition, we discussed that all particles have matter and their antimatter. So once we are talking about proton, so antiproton is with proton only, right? And if we are talking about electron, so with electron we are having positron, right? So we are not going to
Okay.
combine like electron plus antiproton, proton plus positron like this, right?
Okay. Also, is like how we know like electron is like orbiting the shell, like it's orbiting in shells. So is the positron also gonna be like
Hmm.
rotating in like around it?
Yes, but we only need to discuss about their names and their some properties, right? We are not going to talk about their motion because that is related to their quantum numbers, and that is a complete detailed topic in quantum physics. We will discuss some basics of quantum physics in this chapter, but not in detail, because that revolution and that angular momentum is a very detailed and very advanced topic in it that you are talking about, right? Because for that we need to calculate their angles also, that what is the angle between electron and positron. So with the reference of electron, then we will find the rotation of positron also, right? So for that we need to find out their angular momentum, also their angular movement. So then we are able to find out their movement and their motion, right? So
Okay.
in this chapter, we are not going to discuss about their motions or like their directions. We are only going to talk about discuss their names, their charges, and their additions. Only that one, right?
Okay.
Because from this chapter, question is not much very detailed. It will be like 6, 7, or maximum 8 mark. So the question from this chapter will not much lengthy, just like the wave and electricity section, because this is most like the theoretical one and the most easiest chapter. So that's why this will be not going to be included in detail in your exams. After that,
Okay.
this is the basic idea for antimatter, that gives you the concept that in this chapter we are going to talk about the antimatters and different types of matters also, rather than electron, proton, and neutron, because these are the basic one and we already have knowledge of that, right? Okay, so let's suppose if we are also talk about some other new elements. So there are some new elements. Let's suppose if we start with another one. So before that, we need to know about some basic topics. That is the topic of isotopes. I hope you already know about that isotopes, right? Same atomic number, different atomic masses.
Yeah, yeah. We did this like in physics
Yes,
last year, also chemistry in both years.
yes. So I'm just skipping that topic for the time being, right? If you want to revise that
Oh,
one, so we will discuss in next class, right?
all right.
And the next one is again the same concept, alpha, beta, and gamma particles, right? Do you know about alpha, beta, and gamma, their properties?
Yeah, alpha is it's the least what's it has a word
Penetration
for it.
power,
Ionizing power.
greatest ionizing power, least
Okay, yeah,
penetration power.
yeah, okay. It has the least and then penetration power and the most ionizing power.
Yes.
Then
Beta.
beta is like in the middle, and
Yes.
then gamma has the opposite to alpha.
Yes. The greatest penetration power and the least ionizing power, right? And alpha is
Yeah,
equals
also
to. Hmm?
gamma is also it's basically just like electromagnetic. It's
Yes.
like a electromagnetic wave, and alpha is the helium. It's the
Yes.
ion of helium, and it's also the heaviest, so
Yes.
therefore it like deflects more as well.
Okay, that's nice. So you already know about some basic knowledge about these radiation, because now next particles that we are going to talk about is from the radiations process, right? Because in radiation we also get some different particles besides of alpha, beta, and gamma, because those are the journal that we normally use in our daily life. But if we go into the microscopic level or in the nanoparticles, so then we have some different particles. That is the branch of quantum physics in which we are going to discuss about those nanoparticles, right? So let's suppose if we continue with some new particles. So the first one, or the particle that we are going to discuss first, is known as neutrino emission. Neutrino emission, because you know that there is also a concept of nuclear fission and nuclear fusion reaction, right? So in that process we are also getting different elements that we never discussed before. So in this chapter we are going to discuss about that. So basically, okay, so the first particle that we are going to discuss about is neutrino emission. So in neutrino emission, what we are going to discuss about, we are going to discuss about the electron. This is basically related to the electron. So the basic definition for neutrino emission is an electron. An electron neutrino is a type of subatomic particle with no charge and negligible mass. Now you can see we are talking about those particles which are almost like the negligible mass, right? So that's why usually we didn't study about these particles, because these are almost like the massless quantities, right?
Yeah.
Which is also emitted from the nucleus. So basically, when we talk about the nuclear fission or nuclear fusion reaction, so during that reaction, we know that we just combine the nucleus or we just split the nucleus. So during that reaction, a electron neutrino is a type of subatomic particles that comes out from the nucleus in the reaction, right? And basically, there are two types of electron neutrino, right? And in this chapter, we are not going to discuss about in very much detail, right? So sometimes you find that topic is very much short. We just talk about definition, their charge, and their combination, and that's it, right? So don't worry about that, because topics are not going to be in very much detailed. So for neutrino emission, we need to write more things about this. That will be the antineutrino is the antiparticle. Now we are just finding the opposite charges of the same particles, right? So we just mentioned neutrino emission. So it means that the anti-neutrino is the antiparticle of a neutrino, right? And how they produce? So their production process will be like this. Let's suppose if we talk about the electron anti-neutrino. So the electron anti-neutrinos are produced during beta decay, right? So when we were talking about that alpha decay, beta decay, gamma decay, so during beta decay, this element electron anti-neutrino will produce, right? So this is the process that how this electron anti-neutrino will produce. And if we talk about electron neutrino, right, that is for the first definition that we were talking about, an electron neutrino is a type of subatomic particle. So actually that will produce in beta positive decay, because there are two types of process, beta negative, beta positive, because now we know that that for electron we are having a positive charge also, positron. So same goes for beta. Beta is the negative one, but there will also be a anti-particle that will be beta positive decay, right?
Okay.
So next one be electron, neutrinos. You just need to remember one, then next one will be the opposite of the first one. Just like if we know about that electron anti-neutrino are produced during beta negative, so electron neutrinos are produced during beta positive decay, right?
Okay.
So this is the concept, right? And now if we talk about their symbols, so their symbols be like this. The first one is for electron neutrino, and second one is for anti-electron neutrino, right?
Okay.
It might be like a difficult one in the start because names are like mostly same in neutrino, neutron, anti-neutrino, electron, anti-electron neutrino. So it might be like confusing one, but after completing all the elements, then we can easily identify that which one is related to which concept. So then it will be very easy, right? Then we will make a simple chart. Okay. So this is
Okay.
one particle, and this is the second one, right? So in this concept we will discuss about four different new particles, right? The three are related to the basic, and this is from the radiation of the particles alpha, beta, gamma, right?
Right.
Okay, so now any confusion? Okay, so now if we consider some other particles, right? Because these are only related to the beta emission, right? Beta positive, beta negative, right? So we are just writing this one as a separate. Now, if we talk about some other, because this is related to only negative part, that is electron, beta. Now, if we talk about some positive ones, so let's suppose if we consider the positive one, so there is a concept of quarks, right? So now we have two categories, neutrino for the negative one and quarks for the positive type one, right? So if we talk about the quarks, so quarks are also the fundamental particles. These are also fundamental particles. So these are also the fundamental particles that make up. It is also going to make subatomic particle just like the neutrino. Such as protons and neutrons. So now you are getting the concept that if we are going to make a one proton or one neutron, let's suppose, so the formation behind the proton and neutron is of like the quarks. Basically, quarks combine and make protons and neutrons, right? So this is like the positive and the neutral category, right? So let's suppose if we further divide into the more categories, so more categories will be like, if we only talk about proton and neutrons, so for protons and neutrons, so the category in which proton and neutron falls is known as hardons, right? So if they ask you about the hardons, so you need to know that proton and neutrons are in the category of particles that are known as hardons, right? And if we want to define the hardons, so we can easily define the hardons as any particle that is made up of quark, right?
I prayed.
Okay. So basically, we were talking about quarks, right? So just leave the neutrino, right? So that was related to electrons, right? Just leave the negative part for the time being. We are only focusing on the positive part, right? So for positive part, first we discuss about proton and neutron. These are the main particles, right? And if we talk about
Yeah.
the branches or the the subatomic particles. So in subatomic particles, we are having quarks, right? And then in quarks we are having there also subcategories, right? Their name of different quarks, right? So that's how the quarks work, that quarks combine and make protons and neutrons, right? And the category, this hadron is basically the category. This is the name of the category in short. So hardons is the category, and that hardon is still defines the same thing, any particle that is made up of quark, right? So we know that proton and neutrons are made up of quark. So that's why in journal we can say that protons and neutrons are hardons, right? In hardons we are having two categories, protons and neutrons, right? It will be like a chain in form like this. Let's suppose first of all we are having hardons, okay? Then in hardons
Okay.
we are having two particles, protons and neutrons, right? And then we know that protons and neutrons are made up of quarks, right?
Okay.
So protons are also made up of quark and neutrons are also made up of quarks. Now the next step is we need to discuss that what type of quarks made proton and what type of quarks made neutron. So this is the branch like structure, right? So basic categories, hardons is the main category that we are talking about, and in hardons we are having a different range, right? Okay. So now next step is to know about the different quarks, right? So then we just complete this chain reaction after quarks, that what type of quark actually combines and make proton and neutron. Okay. Any confusion?
No, no confusion.
Okay, so the next concept is related to the name of the quarks, and basically we used to write flavors of the quarks, right? So we can say that, and basically to make proton or neutron or any particle from quark, right? Because there are different particles. We are only talking about the journal. So there must be two quark or like six quarks, sorry, two or three quarks make a new particle, right? So there must be a combination of two or three quarks. Okay. And in our syllabus, we are going to discuss about the combination of three quarks, right? So there is a group of three quarks. So that is known as the six flavors, or in simple words, we can say that types for quark, right? So now there is a specific pattern and specific sequence. What is the sequence? Let's suppose the very first one. The very first one is the U, and I will write the name afterward. The second one is for the C, and the third one is the T. The fourth one is the D. Fifth one is S, and the last one is B. Now there is a particular pattern, and what is the meaning of this particular pattern? The name that starts with U is the up. So this is the first flavor of the quark that is known as up, and the second one is the charm. These are like to be the name of the different fragrance, the charm, the up, and the third one is T top. Now we are writing, you can just take the reference like this. We are writing up, charm, top in the upper order, right? So might be they will be the positive ones, right? Or the positive number or the greater number like this. That's why we are writing in upper column. Now the second one are the opposite. Now you can automatically sense it like this. For the up, we are having down. It means it is opposite to the up. Then we are having a charm that is something different. So for S, we are having strange. And for B, we are having bottom. So these are the six flavor of the quark that you need to study in your syllabus, right? There are no other quarks included. These are six flavors that for that we need to discuss about their formation and their numbers, that what are their numbers and what are their charges actually and what are their properties, right? And we know that we are having quarks, so there will be anti-quarks also, right? The antiparticles.
Yeah.
Okay. So now let's suppose if we talk about their charges. So the charge on the hadrons, okay, we didn't use red color. So let's suppose if we want to write the charges, so all the quarks which are on the top column, that's why I write them in the sequence. So their charge will be equal to plus 2 over 3e, right? So up, charm, top. These quarks have charge equal to plus 2 over 3e, right? E means the same charge of electron. So all of them are having a same charge like the positive one. So you can easily write them up, top charm in the positive category, and the rest of them will be the negative one. But their values will be different. Their values will be minus 1 over 3 E, right? And the derivation and the concept and the detail behind these charges are not important because that is not included and they are not going to ask in your exam also, right?
Yeah.
So only there are two type of charges for each flavor of the quark. Either it is positive 2 over 3e, otherwise minus 1 over 3e. And bottom side consists of minus 1 over 3, upper side consists plus 2 over 3e. Okay. Now we discuss about the six flavors of quarks. So there will be anti-quarks also, right? Like anti-up, anti-charm, anti-top, anti-down, anti-strange, anti-bottom, right?
Yes.
And before that, let's suppose if we consider one example that we already left out in the chain reaction, like the proton and the neutron, right? So let's suppose if we talk about the proton. So what are the name of the quarks that actually made protons? So let's suppose it is made up of two quarks, because I mentioned that we are going to discuss about in like series of three quarks. So we take two quarks from the up category and one quark from the down, right? Now you can see the charges. For up, we are having plus 2 over 3, like 2 plus 2 over 3 values, plus 2 over 3 plus 2 over 3. Then we are having one down, that is minus 1 over 3e. So let's suppose if we just continue the process for the proton, so what we will get if we continue the process over here? So 2 up means we are having plus 2 over 3e, then plus 2 over 3e, then minus 1 over 3e. Okay. So if you combine the value, like if you just calculate with the calculator 2 over 3 plus 2 over 3 minus 1 over 3, so what you will get? 1e, positive 1e. Okay.
Because so when you get plus 2 over 3 plus 2 over 3 will give you plus 4 over 3 and then
Yes.
minus 1 over 3. So you're going to get 3 over 3. So that's going to be 1.
And that is the positive 1e, because sign is very much important because we are talking about antiparticles also. So now you can see that the charge of proton is plus 1. So today we discuss, and today we are going to know that how the charge of proton is plus 1, because it is made up of the quarks and those charges of the quarks like this, and they make proton plus 1, right? Now again there is a mystery. Now we need to know that how quarks are made, what are the particles. So this will go so on, and they are still in the process that they are discovering new and new particles. So that is very detailed theory. So this is the one example of a proton. And if you want to make for the neutron, so what will be the formation of the neutron? Because for that you need to be your value 0.
Okay.
That will be 2 down, 1 up. Okay. If we use 2 down and 1 up, so your value will be equals to 0, right? Like 2 down and 1 up, because the value of up is plus 2 over 3 and the value of down is minus 1 over 3. So that minus 1 over 3 minus 1 over 3 will be equal to minus 2 over 3. Then plus 2 over 3 minus 2 over 3 will be equal to 0 neutron, right? We will also discuss that in detail, but because in question they usually give you the reference and you just need to combine the values and just find the answer. Okay.
Okay.
And if we talk about these six flavor in antiforms, this is just like a different game or type of a game or different type of a puzzle. We are just combining and finding the thing of different colors and joining them, making the things. So we are having anti-up, anti-charm, anti-top, because you got the concept all having the negative charge. So I'm writing the names with the opposite. We are having anti-up, then we are having anti-charm, we are having anti-top, also anti-down, anti-strange, anti-bottom, right? And if you want to draw the symbols, so symbols will be like the same, only with different marking like this. Because in previous neutrino, we just mark the bar over it, right? So that bar gives you the concept of anti-particle. And the T will be the same. We are having for down, anti-strange, B, anti-B. And the charges will be different. For the first category, we are having charges -2/3e, and for the lower category, we are having +1/3e, right? So these are the matter and antimatter and their charges, right?
Right.
Okay, any confusion?
No.
Okay, so is it enough or want to continue with a few more things?
How much more is left?
Actually, there is one more category of leptons. I think we will start that one in next class, right?
How long is it?
It will take one more class because there are two concepts of mesons and leptons, just like it will take the same time that we take today. So that will be completed in next class. After that, we will be discussing the past papers questions, right? So I think
Okay,
we have
whatever.
to end up till quarks today because we discuss about neutrino, quark, and for next class, before that, you just revise isotope, Rutherford, and one more thing, that radioactive process alpha, beta, gamma, right? Because their properties are also going to be asked in past papers question, right? So revise them, and if you find anything difficult from that, so let me know. We will again discuss that thing. Otherwise, we will continue with leptons and mesons, right?
All right.
And one more thing, just leaving the class before that, let's suppose for proton we discuss that two up and one down, right? So let's suppose if you need to make anti-proton, right? So what you need to do? The same thing, two anti up, one anti down, right? So formation will remain same, only names will be different, right?
Oh, okay.
And same goes for the anti-neutron. Two down, it means two anti down, and one up means one anti up. Okay, so that will give you the value of anti-neutron. Now this will be not very much difficult. I hope that will be like a simple mathematical game with the different charges, right?
Yeah.
So mostly they just give you the value, or mostly they ask you about the name, that what is the meaning of, and how, what is the category of this one or that one. So just remember about quarks, because today the main focus on our topic is quarks, right? Neutrino is different. Just take away from this section of quark, and then the just like the same pattern of quark, we are having leptons and mesons. for the negative and the other particles, right? So that we are going to discuss in our next class, right?